So there's this concept in physics called energy. Energy is the stuff that makes things do things. So mass is what you're made out of, and energy is what pushes and pulls that mass around and creates forces and creates everything that you see happening in the world around you. And energy comes in a lot of different forms. It can come in the form of a moving object. It can come in the form of something sitting in a gravitational field waiting to fall. And the type that we deal with in chemistry the most often is chemical energy. So the energy that's stored in atoms and molecules that burns to make chemical reactions happen. Food stores chemical energy, and if you look in your kit, you have a small candle. This candle is made out of beeswax, which is essentially bee food, even though it's more of bee housing, but the bees are using it to store energy. So the first thing that comes in your kit is the lab stand for the calorimeter. This is the cardboard base, the metal rod, the black hoop, and the metal clamp. The ring and the clamp will be found in a bag that also contains some aluminum foil and some wire. And that aluminum foil and wire can be useful in putting together the lab stand, so that's why it's there. You'll want a graduated cylinder, thermometer, candle, and masking tape. And you'll finally want to have some way of lighting your candle on fire. You could use matches, you could use a lighter. If you don't feel comfortable doing this, get a parent to help you out. And you'll also need to have access to water. So this is all the stuff you are going to need to put together your calorimeter. So I'll show you how to put together your lab stand for your kit. And we're going to be using a lot of masking tape that might seem a little bit unprofessional, but we had looked into including a professional lab stand in your kit, and it would have cost about 50 bucks. Well, this cost a lot less. So bear that in mind, and this does work pretty well. So why spend more money when you can get more science? Now I'm going to take my lab ring and clamp and attach it to the base just to show you how that goes together. The hoop is going to hold the can. So I'm going to take my hoop off, and I am going to take my can and attach it. One little note about this can, you're going to want to pull off the tab because this is going to get in the way of the thermometer when you put it into the can. So you just want to go and get rid of it. Now I'm going to tape my hoop to the can, and I'm going to be very generous with my masking tape. I want it to hold for the whole experiment. And now my hoop is taped to my can, and I can attach this to my lab stand. I want the candle a couple of centimeters below the can, so this is a pretty good height right there. And that's going to be where I'm going to want to attach my can to my lab stand. So I'm going to take my metal clamp and attach it. Now this isn't going to hold it all the way, so this is where more tape gets involved. So I've taped up the ring and clasp, and I've also put some tape on the base to make it stand up more upright. You could find that useful, you don't have to do it. You might find the wire that comes in your kit useful for holding the bottom of the can. You don't have to do it, but if you want to, you can. The aluminum foil may also be used to adjust the lab stand, and you may also want to put the candle actually on aluminum foil for your experiment to catch any wax that might come off of it. If you're using a soup can, you're going to want to take some aluminum foil, put it over the top, and then cut a hole in it big enough to put your thermometer in. The final thing that you'll want to do before you start taking data and lighting candles and stuff is measure out 100 milliliters of water and put it into the can. And this will stress everything, and you'll probably have to put in some more tape after you've done this. The water you use should be cold or room temperature. We are going to be heating it up using the candles, so you don't want to be using hot water. Now you'll want to take your thermometer and put it into the hole in the can and let it sit for about a minute. Once your temperature is equalized, you'll want to read your thermometer. You'll want to read the Celsius scale because that's going to be a lot easier than having to do this in Fahrenheit. And so my first temperature is 21 degrees Celsius. So now that I have my starting temperature, I'm going to light my candle, put it underneath my can, and record the time. I'll go do that. I'm going to give my candle 10 or 15 seconds for it to warm up just so that it's nice and hot when it goes underneath the can. Then record my time. So I'm starting my experiment at 11, 17, 19 seconds. The closer your can and candle are together, the better this experiment will work. My can's actually up a little bit on the high side, but I wanted you to be able to actually see what was going on. I'll bring the camera closer so you can see. You'll want to wait a few minutes for the water in your can to warm up, and I'll come back and take those measurements once that's done. Well, it's been about 12 minutes. My temperature's risen quite a bit, and I'm going to go ahead and record the time that it is now and the temperature it's at, and go from there. So I'm going to use that information to figure out how much energy is stored in the candle. So I hope you found that interesting. Wax has a lot of energy stored in it, and you've just figured out how much that is using basically just a pop can. So that is pretty darn cool. See ya!